Okay, so here we are. Let me just turn the radio down a second.
And the people who ran the funeral owners, they knew that a lot of times we would come there just to get out of the heat, but they had one kind of unwritten rule: you couldn't come in.
Okay, well that's Snap Judgment. Who doesn't like Snap Judgment? One of my favorite shows. So here we are back at 10 Old Stage Road. It's the 30th of October. At some point I'll get all of these videos collated. We're going to be working today specifically on the air sealing and making the vapor membrane that's under the slab connect to our air barrier that's connecting to the bottom beam of the timber frame what we have here. So we have here right now, I may move the light a couple of times just to get a better view here. But we've got, this is the area we're talking about. And what we have now is, I'll do it on this side, we've got a slab that's been poured to cover up the dirt that was there. Under the slab we have this 10 mil vapor barrier called Stego. We then have in many places a very nice poured curb which is closing up the exterior rock of this rubble wall. So the entire foundation is just stacked up stones. Here we had a rotting part of the beam. It ends up that at some point in the past, from the outside it seems, they put another ledger board. It looks like a good 3 inches thick, maybe 2.5 inch, and that's fine structurally, and they tied it into both the beam bits here. I haven't decided whether to keep, I probably will just leave that alone. So the treatment, what are we doing? Well, I have this this membrane here that I've cut into strips. This is a Proclima product, as you can plainly see. This is called, let's see if I've got any place where I didn't cut it off, Mento 1000. So the benefit of Mento 1000 is completely airtight. Air won't blow through this. Why is it better than plastic, which is what people used to put on walls for a very long time? It's better than plastic because, unlike plastic, it's vapor open. That means if there's water vapor or gaseous water on either side of this, it creates what we call a vapor pressure, a differential between the vapor concentration on one side of the vapor retarder or the plastic, and on the other side, the inside and the outside, we could call it. And vapor moves just like heat does. It moves from a higher concentration to a lower concentration because, as we always say, nature likes balance. And if you have a higher concentration of vapor in one place and a lower concentration in a place that's just adjacent to that, the vapor will actually drive, it's even called the vapor drive through the various bits of the wall until it can equalize that, or until it comes against a surface that it can't get through, where when the concentration is high enough it'll turn into water, or if the temperatures are low enough it'll condense into water. So what a vapor barrier like this does in this particular situation is, and I'll show you a place where I've actually done the work. So we have our vapor barrier here, which actually has a rip here. That's gonna have to be repaired. Then we've got it coming up and onto our curb, which, like I said, we have in a lot of this particular part of the house. And then we have the membrane, which has been attached with what's called a, well, this happens to be Sigo Resun is the name of the product, but it's an acrylic bonding tape. It's unlike a regular tape. Regular tape has a glue. That glue actually off-gasses or evaporates over time. That's why when you go back into an old photo album and someone used old-fashioned cellophane tape to tape the pictures in there, they all fall out and the tape is brown. There's nothing left of it. Well, this is an acrylic bonding agent, and what that is that on the inside of the tape is a thin layer of acrylic. Acrylic is a non-toxic, we use it for paints and things of that sort, but the nice thing about an acrylic is that once it sets, it's hard and stays that way. And what we have here is, with this tape, it's called a pressure activated tape because you have to press hard on it in order to squeeze the little bit of acrylic bonding agent that's on the tape into the molecules at the top of the surface that you're taping it to. After about 12 hours, that sets, and it is impossible to rip it off without destroying the underlayment of the layer that it's on. So if I were, this was done about a week ago, if I was going to try to rip off that Resound tape right now, I'd either be ripping the Mento to bits or I'd be tearing quite a bit out of the stego, that yellow moisture barrier. Okay, so here's step 2. In step 2, we have what I was doing first, which is taking the vapor barrier and putting a clear silicone caulk down. It's not a perfect job. It's not sticking as well as I'd like to, but I'm not that worried about it. The chances that a whole bunch of vapor is going to drive along the entire bottom of this and up and then condense here is relatively low. But then I have this vapor open barrier there, and that vapor open barrier is specifically going to let any trapped moisture that could get there go into either the house or to the outside, depending on where things go. But this is airtight and vapor open. So the space that will be occupying here is right here. We'll put the bottom of the Mento here, and then it will come up and tape to this beam. And I'll just give you an idea of what that will look like before it's taped. There we go. So there we have it. You've got the Resound tape will be put here. This will be brought down so it makes a nice square, and then that'll be taped onto there, creating a really good air seal between the foundation and the beam. Now we have some odd things. We've had to do some replacements. There's a video on that. And we have this place here where the stones under the beam were supportive, so we couldn't actually put the moisture barrier all the way under. And here, what we'll be doing is we'll be taping this material, which has still got a couple boards in it holding it up, onto the bottom of the beam with a piece of our vapor open material, so that any moisture that gets built up there will come into the house. It won't be very much. It'll not be any bulk water, but it needs a place to dry to, and the inside of the house is one place where that can happen. So what we're going to do now is we're going to move these. These are the floor joists. You can see that these have been squared off. Each one of these has a number on it. The number corresponds with one of these. And we have 5 or 6 of these. They're numbered on the other side. You don't see any numbers here. But in order to clean this area out, vacuum it, and do this treatment without a lot of stuff in the way, I've got to first remove these hand-wrought floor joists. So you can see they're hand cut. You can see that someone used a, pull it back a little more to get a little more view of this. And the other ones, this one shows it much better, how the draw knife was used to clean off the bark. And then a hewing axe probably, and a froe was probably used to mash that into place. So this is a pre-industrial technique. I believe the house is from the 1850s, which would mean that this was probably done, cut, and hewn before the Civil War, at the very dawn of the Industrial Revolution. So we have throughout the house we have a mixture of hand-hewn and sawn pieces of wood, which shows exactly where it was. I mean, hand-hewn you can do on your own. You have to go to the sawmill to buy sawn wood. And there were a number of water-driven sawmills in the area. Okay, let's get to it.
The reason why none of us